This is lesson 67 of the Quantum Mechanics, a mini lecture series titled Tensors. Now, a tensor is basically just an arrangement of numbers similar to a matrix. And we use what's called tensor products to describe a system that's made of multiple subsystems, okay? So a system here, let's call it X, made of multiple subsystems. Let's call it X1, X2, X3, X4. Okay, it's basically a larger Hilbert space constructed from the product of smaller sub-Hilbert spaces, right? Let's take the following example. Suppose we have two electrons, each with a spin state denoted by this, okay? Spin up, let's say, two electrons with a spin state, spin up. Okay, the tensor product of these two spin states is given by this. This means tensor product. Okay, this circle with an X in it, tensor product. It's just basically this, right? Another example, let's suppose I have the quantum state psi. You could say A up plus B down, and I have phi, C up plus D down. So the tensor product of this quantum state is then given by the following. Okay, show you how to do this. So you simply rewrite it as follows. Now, what you do is you take the multiply. So it's basically just like expanding parentheses in algebra. Here's how you do it. Okay, so you first multiply the numbers, take them out, AC. Complex numbers, AC. Then you have up, so up in this case, and up. Tensor that, tensor these two. Plus AD, so AD. You've got up and down, up tensored with down. Plus B, C, down and up. Plus B, D, down, down. And here's what you'd get. Just cleaning it up, you just put the two arrows in the first bit here together in the same ket, and then plus AD, same thing here, plus BC, down, up, plus BD, down, down. That's how you do it. Okay, it's just similar to expanding out parentheses. And tensors can also be applied to column vectors as follows, right? So suppose I have a column vector given by this and another one given by this. The tensor product of these two is this. Okay, so I take this element here, multiply it by this, and I'll take this element, multiply it by this element to get this here. And then I take the 0, multiply it by 1, and the 0 multiplied by 0. Simplifying, I get the following. That's how you do it. Okay, similarly here, 1, 2, 3. If I have 3 elements in this case, what I do is 1 times 4, 1 times 5, 1 times 6, and then 2 times 4, 2 times 5, 2 times 6, and then 3 times 4, 3 times 5, 3 times 6. Right, and I'll work that out. So that's how you do the tensor product, right? As an exercise, try and find the tensor product of this. Okay, but that's the idea. It's a very simple matter, okay? Provided you've got not many elements in each column vector.